Hi, I'm Neil.
I'm Melinda.
I'm Steven.
And we are Team Elefont.
We are doing the project Steganography.
And we're going to show you how it's implemented and how it works, as well as the rundown of our code.
Hello, my name is Steven again, and I'll be going over the GUI functions first. I'll be going over the steps. The first step, which is loading the main image. Okay, and the second, we have our 10 different images and our 10 different embedding techniques. I'll do image 1 and one of our embedding techniques, which is odd even red on the odd row. So click embed and it should show up right here with the image hidden within our original image. And lastly, I will do image number 7 and odd even green on the even row. Now we should have all 3 of our images that we chose hidden within the main image. Now we have our 10 different recovery techniques, which should correspond back to the embedding techniques. So first I did the odd even red on the odd row. So if I were to choose that and recover, here I should recover the very first image that I hid within the original image. And second, I did the odd even blue on the odd row. This is the second image that I hid. And lastly, odd even green on the even row. Okay, yep, this is the very last one. And next, I will be explaining our special features, which is flipping, rotating, and mirroring our image to hide. So if I were to click rotate, I can rotate 90 degrees. And if I were to embed this into our original image and to recover, it should come back out the same way that I rotated it. And next I can flip or rotate or mirror our recovered image right here, bottom right, any way that I would like. And finally, we have our saving and loading features. So if I were to save our embedded image right now and press load, it should be saved in a folder. And it's this one, embed 608. And if I were to open it, it would load the image with the embedded pictures that I just embedded into the original image.
So as Steven showed, this is our overall design for the GUI. I'm going to be presenting the code, and I'm Melinda, once again. So here, App Designer basically did all the code for the formatting. So as you can tell, it made each property. And so we added our own properties. These are the ones that we need to save and then reuse for when we call back some functions. So we have the load main image button. The code here is saying that if no main image is chosen, then nothing will show on the main axis. And then we have the image to hide button group. And so in order to implement this, we use the switch function. And so when each button is pressed, it would read either hidden image 1, 2, 3, and so forth. And it would be shown on the image to hide axis. So one of the challenging parts we had in this project was how to embed all 10 photos into one. So here we would make the embedded image also our input. So as we ran it, it would add the embedding technique onto the same property. And so we also use the switch case function. It works because we were able to find techniques that work together. So even if one technique is added to the same layer, it wouldn't interfere with the recovery of the other one that was saved in the same layer. And then that would be shown in the embedded image axis. And then here we would have the load embedded image button, and then we have also a save embedded image button. And so this code allows us to save it, and it would save automatically as embed.arandom3numbers.png. And then we also have the recovery technique buttons. And so same as the embedded techniques, we use a switch function, and it would call each function as shown here for the recovery techniques. And then these last two functions are for the special functions that we have to either flip it or mirror it or rotate it 90 degrees. And this first one would be displayed on the image to hide and would alter the format of how your hidden image would look like. And then we also have this one, which is the one to flip the recovered image. And then the rest of the code is all the app designer and the formatting code, as I said before.
So first off, I went to create the flatten function. The flatten function basically makes the hidden image into zeros and ones. For the expansion function, we try to expand it into a red layer, green layer, and blue layer. These two should be switched. For the embedded technique, for this one, the odd and even, I skipped every row. So this would be every odd row. So what I did for this technique is that I made the white pixels, or pixels that are 1, into odd. What this code means is that if the hidden image pixel is white, then we'll make the main image pixel odd. Then the opposite would be true. If the hidden image is black, then the main image pixel would be even. However, we also have to consider the other method I'm using, which would be divisible by 3, and we have to set those conditions as well. We have to make sure those conditions don't change. So here would be the code. And then I did that for the red, blue, and green layer. For my other embedding technique, it's the same technique, but except I'll be looking at even rows. For divisible by 3, for this code, I will made the hidden image pixel, if it's white, then we make the main image pixel divisible by 3, and the opposite would be true. If the hidden image is black, then the main image pixel is not divisible by 3. Now the code is a bit shorter because we'll be only looking at if the number is odd or even to make sure that the previous embedding technique is not affected. So here would be the code for recovery. For recovering of odd even, we look at each pixel. If it is even, then we change the even pixel to black. And if the embedded image pixel is odd, then we change that odd pixel to white. Now, of course, since we're skipping every single row, we have to look at the rows in between. By doing that, we look at the top row and bottom row and look at every pixel for it. So if the top row is black, for example, and the bottom row is black, then it would be the middle image would be 0 or black. But if they're switching, such as top is black, bottom is white, then the middle image would either be black or white. Same thing if you had top and bottom both be whites. For dividing by 3, same concept, except that we'll be looking at if the image is divisible by 3 or not. If it is divisible by 3, we change it to white. If it's not divisible by 3, we change it to black. Hope you guys enjoyed the video. Thank you for watching.